All right, we're going over 4.3 properties of logarithmic functions preparation. So we're going to go over the product rule, the quotient rule, and the power rule. Okay, so first, the product rule. So I'm going to dive right in and do some examples. Now this is almost, it's very similar to the product rule of exponents because logarithms and exponents are closely related. So basically, if we have these two numbers multiplied together within here, then what we can do is we can break this logarithm apart. Right, so the logarithm of the first factor here plus the logarithm, same base, of the second factor there, right? So logarithm base 5 with the argument of 6 times 9 is the logarithm base 5 of 6 plus the logarithm base 5 of 9. And that's it. Let's move on to the next one. Now in this case, you're adding these together. Okay, logarithm base 7 of 8 plus logarithm base 7 of 12. Now these both have the same bases, that's important. So what we can do here is instead we can say, well, that's the same as the logarithm base 7. What we can do is instead of adding these together, we can take both of these arguments, the 8 and the 12, and we can multiply them together. So we can say 8 times 12. Right? So we can do this both ways. If it's together and these are being multiplied together, we can tear it apart into an addition. And if they're apart, but they have the same basis, we can put them together and we can multiply. So we'd go to log base 7. 8 times 12 is 96. Just like that, right? And we can't simplify that, at least not nicely. So that's it. Okay, move on to the next one. The next one is saying that we have 3 times x there. So the same thing we did with the constants, we're going to do with a variable now. So we'll end up with log base 3 of 3 plus log base 3 of x. Now, whenever you can simplify one of these logarithms, you really should simplify the logarithm. So the question here is, well, 3 to what power is 3? If these both match, that must be 1, right? So again, 3 to the first power is 3. So log base 3 of 3 is simply equal to 1. And if these both match, right, the base and the argument match, then the exponent must be 1, right? So they're basically saying this. 3 to what power is equal to 3? And you'd be like, oh, it's 1, right? 3 to the first power is equal to 3. That makes sense. Okay, so then you would have 1 plus the logarithm base 3 of x over here. This one's going to be a little bit different. We're using the product rule. Later on, we're going to learn the exponent rule. But if you use the product rule, this is really the same as saying, well, that's the log base 4 of x. And because it's x to the third power, that's really saying x times x times x, which is log base 4 of x plus log base 4 of x plus log base 4 of x. And that's it. Okay, so let's move on to the quotient rule. So when we did the product rule, it's the relationship between logs with an argument that's multiplied together turning to addition or addition turning to multiplication. When we're dealing with the quotient rule, it's going to be division turning to subtraction or subtraction turning to division. And again, these are related to the exponent rules for the product exponent rule and the quotient exponent rule. So if you notice that, then you are correct. Okay, so let's dive in and do some examples of this. Okay, so in this case, we would say that the log base 4 of 7 over 9 is the same as log base 4 of 7 minus the log base 4 of 9, right? So it's the numerator minus the denominator, right? Now in this case, this is log base 5 of 6 minus log base 5 of x. So we could combine these together. The first one listed would be the numerator, and the second one listed would be the denominator, right? Next one we see is log base 3 of 27 fifths. So we could put the 27 first minus the log base 3 of 5. Now this one could be simplified, right? Because 27 is equal to 3 to the third power. So if we simplified log base 3 of 3 to the third, right, then that must be equal to the 3, right? So that whole thing's equal to 3. So we just replace log base 3 of 27 we replace that with 3. Because 3 to what power is 27? Well, 3 to the third power is 27. So 3 minus log base 3 of 5. Okay, let me move over here. So we have log base 6 of 28 minus log base 6 7. So, because these both have the same bases, we can mush these together, right? So we can rewrite this as log base 6 28 over 7. Now in this case, 28 over 7 will reduce, right? Because 28 divided by 7 is simply what? 28 divided by 7 is 4. And there we go. Okay, so we went over the product rule, the quotient rule, and now next is the power rule with logarithms, okay? And this does have some similarities to some of the exponent rules, so there we go. Now, if I want to rewrite this, basically all you do is you take this exponent there and you pull it to the front. We're going to do more manipulations later, but right now we're going to keep it simple. I'm just going to pull it to the front, which means we'll just end up with 2 log base 5 of 4, or 2 log base 5 of 4. Okay, right here again, we're going to pull this exponent to the front. So we end up with 5 log base b of x. Over here again, we're going to pull the exponent to the front, except you would say, oh, there is no exponent, it's just a radical. Well, we have to do a little manipulation. We have to turn that radical, right, that square root, into an exponent so we can use the rule. And the exponent is 1/2, right? So we're going to take this 1/2 exponent. Again, the understood or implied index of a square root is a 2. If you don't see anything, it's a 2. It's understood to be a 2 or implied to be a 2. So we're going to end up with a 1/2 exponent here. We're going to pull that to the front. And we end up with 1/2 log base b of 7. Okay? Move over here. We need to do the same kind of trick. Again, we have a radical here, so we don't really have an exponent, so we have to do some modifications to get the exponent, right? So we rewrite this as log base 2, but now the index is a 5, and the exponent underneath the radical sign is a 2. So this turns into x to the 2/5 power. I know that's a little bit messy, but hopefully you can read it. So we're going to take this 2/5 and we're going to pull it to the front. So we end up with 2/5 log base 2 of x. That's not too bad. Over here we're in the similar situation in that until we do some manipulations on this, we're not going to have an exponent that we can pull to the front. So what we know is since we have x to the 4th power on the bottom, if I switch positions, take this x to the 4th power and I put it on the top, it's going to flip that sign. So instead of being a positive 4 exponent, it's going to be a negative 4 exponent. So it turns into x to the negative 4th power. So now that we have the exponent, we simply pull it to the front and we're going to drop it down. So we end up with negative 4 log base 3 of x. And there you go.